All right, this is section 5. This is the alternating series test. This one gets pretty complicated, actually. All right, so alternating series test. So first of all, what is an alternating series? An alternating series is when the signs alternate from positive to negative. So it looks like this, right? So there is a -1 to some exponent, to the exponent, and just a regular sequence. Or so this one, it starts with a negative, and this one starts with a positive sign. Okay. So here's an example of alternating series: -1 to the n plus 1 over n. So you know that 1 over n converges. Okay. But what about the -1 over n times 1 over n? So does this converge or not? So let's talk about this. So what does the test say? First of all, it has to be alternating. So this is alternating. Okay. So look at B. Is this alternating? Well, you can treat this as this is same thing as, that's a terrible sigma sign. All right. N -1 to the n minus 1 and 2 to the n minus 1. So yes, this is also an alternating series. Okay. So generally speaking, if the negative is part of an exponent, right, it's going to be an alternating series. All right. So this is an alternating series. So if you have an alternating series, so first condition is you have to follow an alternating series, and the terms in outside of this -1 to the power has to be positive itself. So like 1 over n itself is positive. Okay, and if I take this out, then n over 2 to the n minus 1 in B, n over 2 to the n minus 1 is positive. Okay, all right. So as long as the terms are positive independently of the -1, okay, and the terms are going to 0. If the terms are going to 0, and this here where it says a sub n plus 1 is less than or equal to a sub n, that basically says that it's decreasing. This is basically saying it's decreasing, that the a sub n is decreasing without the -1. Right? So 1 over n, we know that's decreasing because that's same as, if you take the derivative of that, that'd be -1 over x squared. So that's always decreasing. All right, so yes, the 1 over n is positive. The limit is going to 0. Okay, so we're going to say 1 over n is positive, and we're going to say the limit as n goes to infinity of 1 over n equals 0. And let's see. So we want to show that 1 over n plus 1 is less than or equal to 1 over n. Okay, so what did I just do there? So a sub n plus 1, a sub n plus 1, for my example, is 1 over n plus 1, right? And a sub n will be just 1 over n. So this is this a sub n plus 1 less than or equal to a sub n written for this example, right? If you plug in n plus 1, that means I'm replacing the n with n plus 1. That's 1 over n plus 1. And replace the n with n, that's that. So this is true, right? If you have a fraction and the denominator is bigger, then the whole fraction is smaller. So you don't have to say anything than, yeah, that's true, right? So I verified that the terms are positive. I verified the limit is 0. I verify that the a sub n plus 1 is smaller than a sub n, then we could say it converges by alternating series test. And this probably feels cheap because all we did was repeat what they said, right? But that's all it takes. That's all they're asking you to do. Do you know the conditions for the alternating series test? That the terms are positive, the terms are going to 0, the terms are decreasing. As once you've confirmed those 3 conditions, then you can apply the alternating series test. Okay, that's it. Let's look at this one. All right. So, oh, actually, there's 4 conditions. It looks like 3, but this is an alternating series. Okay. I don't know if you have to mention the fact that it's an alternating series. The fact that you're saying it's an alternating series test, Thomas says, no. All right. So this is alternating. Well, let's just double check. We'll just to be sure, it is alternating because of this, because of the exponent here. What's alternating? -1 to the n plus n minus 1. And are the terms positive? N over 2 to the n minus 1 is greater than 0. All right. And what's the limit as n goes to infinity? Limit as n goes to infinity of n over 2 to the n minus 1, that's equals 0. And then, what about the terms? So what about n plus 1 over 2 to the n plus 1 minus 1? How does that compare to n over 2 to the n minus 1? Okay, so that one's actually pretty bad. Okay, so let's look at that. N plus 1 over 2 to the n, is that equal to n over 2 to the n minus 1? This is where your teacher just dies. Okay, so I look at this and say, this is just too hard, so I'm going to do something else. Okay, what was the other way to show that something is decreasing? What was the other way to show something is decreasing? You take that derivative, right? So remember, we're ignoring this negative 1. So we're going to look at what is the derivative of n to n minus 1? What is that derivative? So we're going to say, so we're going to rewrite as a function f of x equals x over 2 to the x minus 1. Now I'll take the derivative. So that's quotient rule. So that's going to be 2 to the x minus 1 times 1 minus 2 to the x minus 1 times the natural log of 2 times x. Let's just sneak that x in there. Okay. All over 2 to the x minus 1 squared. All right. So now the biggest thing is, what is that numerator doing? So let's clean that up some. So it's 2 to the x minus 1 minus 2 to the x minus 1 x natural log of 2. I'm going to factor out 2 to the x minus 1. Oops. That's going to be 2x minus 2. All I did was distribute the 2. And that's going to be factoring out 2 to the x minus 1. So it's 1 minus x natural log of 2 over 2 to the 2x minus 2. All right, so this part here alone is positive. That's positive. So what's going on here? Okay. So what is this one starting at? Starting at 1. So 1 minus natural log of 2. What is natural log of 2? Natural log of 2 is, that's positive. Right? Natural log of 2 is, what's the word? Natural log of 2 is positive, but it is less than 1. Right? So it's 1 minus something smaller than 1. How do I know it's smaller than 1? Natural log of 2, remember, natural log is log base e, so that's 2.7 with a 2, so that's going to be a little bit smaller than 1, right? In order for this to equal 1, that has to be 2.7 something there. So if it's smaller than 2.7, then that's smaller than 1, okay? All right, so what does it mean for this? So what about x equals 2? If it's equal to 2, then 2 log 2, that's going to be bigger than 1, so now it's bigger. So for x greater than 1, this is decreasing. Okay, for x greater than 1, this is decreasing. And that's enough. Remember, right? So we can start at 2 or something. Okay. All right. So if we start at 2, then it is decreasing, and that's enough. And what are we doing? So it's decreasing for x greater than 2. And so x greater than 1, not greater than equal to 1. Right? I wrote greater than equal to 1, but it's for x greater than 1, this is positive. This is decreasing. This is decreasing. Not positive, but this is decreasing. All right. So what does that mean? So we can still apply the alternating series test, right? So if it's off by 1, that's not a problem. If it's off by 1 or 2 or 3 or 10, as long as it starts decreasing at a certain point, that's all that matters. Because remember, we're always looking at infinity, right? So, but if the question was, is this monotonic? Well, no, it's not monotonic because of that one term. But since after a certain point, it's going to be decreasing, that's enough, okay? That's enough. So this is going to be decreasing after x equals 1. So you can say it's decreasing for x is greater than or equal to 2. Then, so we got what? So we have it's an alternating series because of negative 1. We have it's positive because those terms are positive. We have the limit going to 0, right? You can use L'Hopital's rule or whatever. And I just showed that it's decreasing. So that means this converges. Converges by alternating series test. Okay, that's it. Wow.